Good morning, everybody. Welcome back to lecture number 20. So what is lecture 20? Lecture number 20 talks about the remaining of the example 8. We will finish it today and then go to a little introduction to DC machines, motors. Module 2 is heavy, yeah? Module 2 is basically, I think, one of the most important. It's heavy. So let's recall the equation. What is the voltage regulation equation? V for no load minus V full load over V full load. It's up to you to multiply by 100 or not. If you want to use the notation, there was what? Vp minus Vs prime over Vs prime, right? Yes. Or it can be Vp prime minus Vs over Vs. You can use any of these equations. What else did we have? We have, if I'm having S three-phase base, I have V base. I have S1 phase base, which is basically S 3-phase base divided by 3. Then I have I base, which is what? S1 phase divided by V base, or you can say it's S3 phase divided by 3 times V base. And then I have finally Z base to be what? V base square B space over S1 phase, and these are the equations. So in the previous example, we started by calculating Z base. What was Z base? Z base was 3 times 1, 13.8 over 50,000, or you can say 13.8 voltage square over kilovolt square over 50 divided by 3. 50 divided by 3. Here is, if you replace it with S3 phase, it will be S3 phase divided by 3. So it will be 11,000 ohms. For 1%, it's 100 ohm, 114. For 7%, you get what? 800 ohm. What is part B? Read the question. Part B was asking you, find the VR at full load. What does full load mean? At full load. Wrong. Wrong.
Load مش فوق circuit.
Wrong.
Open circuit.
Wrong. Full load, remember. في الباور قلنا we love rated, صح? So full load means what is designed for. Means rated. Means the load complex apparent power equals to. So the key information here is what? Full load, what does it mean? Rated. That's it. Okay? Okay? What is rated? What we have rated? From this question, we have apparent power is rated. Delta Y, we told you this is delta, this is Y, 208. معناتها الكويل is 208 divided by square root of 3. This is full load. 1%, 7%, it doesn't matter. اللود has to do مع S. فمعناتها S load equals SX R F M الريتد اللي هي كم؟ 50,000. Get it? Get it?
Yes.
Let's continue. 0.8 power factor lagging. We are now experts at 0.8 PF lagging. What does this translate into? Two information. Information number one is I can calculate the real power, صح? For the load. What is the real power? 0.8 times S. Which is what? Calculators. Please. $50,000 times 0.8. What's the unit? Kilowatt. What is information number two? I can get theta. What is theta? Plus arc cosine of 0.8. Which is our favorite number? Plus, don't say 36, plus 36.7. So what is theta I? Theta V minus theta. Let's assume we're taking V as the reference, which is, V reference is the load side, the 208. What is theta I? Minus 36. Okay, man, is it clear? How to translate information from the question to useful stuff? This is useful, this is useful. Let's continue. Again, he gave me parameters. Should I use circuit 1, circuit 2, circuit 3? Did he give me parameters for circuit 1 or circuit 2 or circuit 3? Who said 3? Why? Only two components. So use his information. Why you're looking for trouble? Okay? So now we will solve circuit 3. The one that you're supposed to use if you get stuck in the exam, okay? How does it look like, circuit 3? You have VP. Is it referred to high side or low side? High side. What is the high side? The primary. Okay? So here VP, here we have VS prime. You agree with me? And then we have inductor and the resistor. And here we have IP equal IS prime. And what is VS prime? AVS. What is A? Wrong.
اقسم ال 208 على
Right. So an A is what? 13.8 over 208 divided by square root of 3. You agree with me?
Yes.
Because this is the issue is that coil to coil. Go take your phone. Coil. It's coil to coil. You agree with me?
Yes.
What is this number?
63 volt.
Come.
66
66?
volt.
Okay. What is VS? Remember, this is how it looks like. He's telling you this is 208. Is this circuit single phase equivalent or not single phase equivalent?
I think single phase equivalent.
It is a single phase equivalent. Because it's a single phase equivalent, do we love line to line and okay, is there something?
No.
Are we allowed to use line? We love line to line, but are we allowed to use line to line in the single phase equivalent circuit? So what should be VS here? 120 or 208?
The ratio is wrong.
Yeah.
Okay, what's the correct number?
114.3.9.
فوق سكوير روت فوق.
I said divided by square root فحتطلع على فوق.
ايوه.
تصير square root of 3 times 13.8 على 280. كم الجواب؟ Okay, 115. What is VS? 120. Is VS 120. So what is AVS? 120 ضرب 13.8 على 200. Okay, well, no, I'm complicating things. Okay, if VS is 120, what is VS prime? 115 ضرب 120. كم الجواب؟ 13.8.
Yes.
So what is VS prime? 13.8 angle 0. We're taking this as a reference. Angle 0. We're taking the coil. Angle Y هو reference. Because line current equal to phase current. Let me repeat one more time. Is this my reference or this is my reference? This is my reference. When I calculate the current, هل هو phase current equal line current? In a line, in a node.
Yes.
In another line to the node. I phase equal I line. فالانجل حقت اللاين هي نفسها كانجل phase هي اللي حسبناها هنا minus 36. So minus 36 degree with respect to this zero. Minus 36 degree with respect to zero. Am I recording?
Yes. Yes.
Let's continue. Who wants to do the KVL? Voltage rise or voltage drop? Plus V. Voltage rise or voltage drop?
Minus.
R equivalent P plus J X equivalent P. Minus Vs prime. Can I use my trick?
Yes.
Yes. So what will happen now? Plug in the numbers. Let's get a final answer. What is IP? IP is, we need to calculate IP.
Yes.
IP is what? S over
B.
B. Is this S for one phase or three phase?
One.
Which is what? 50 over 3 MVA or KVA? KVA. Over what is my B?
13K.
Hmm?
13.8.
What is my B? So what current I'm trying to calculate?
IP.
Refer to high voltage or refer to
High.
refer, so I should use high voltage quantity.
Yes.
So what is the voltage that's equivalent? اللي هو هذا 13 point. لأن الباور is the same 50 kilowatt at the load before refilling. هي نفسها 50 kilowatt, no 40 kilowatt. Okay. Do you remember the equation? The question is, should I use real power or reactive power? If I divide by square root of 3, if I divide the power factor, basically I can use one of this. I can use P equal V I cosine theta, or I can use S equal VI. Both are correct. But let's use S equal VI. لأن الكوساين ثيتا هي عبارة عن 0.8. P على 0.8 يعطيك S. واضح؟
Yes.
You get it?
Yes.
So let's use S equal VI per phase, no need to multiply by 3. So what is the IP?
1.2.
Can you do the math?
1.2.
1.2? 1.208 I think. At angle, we already got the angle.
Minus 36.
Minus 36. So let's do the math. 1.2 angle minus 36.8 times, what is RP? Did we calculate it from the previous problem? Yes. 114.2 plus J800 plus 13.8 kilo. Calculators. Do it. If you don't do it, no need to stay in the class. Do something else in life.
14.5 kilo and go 2.7.
Let me do it.
Victor, the argument?
Huh?
Argument.
Our equivalent is 114.2 plus J times 800 plus 13.8 kilo. So what did I get? It's very similar, I think, to you. $14,500 $14,501 at angle 2.7 degrees volts. So what is my VR? It's VP, which is alpha 450 minus VS prime على VS prime. Okay? So 14,501 ناقص 13.8 kilo over 13.8 kilo. 5.1%. Get it? That's how to do it. That's the professional way of doing it. The last question, I'm not going to solve it on the board, but what does he want is in the per unit system. So, in the per unit system, all the steps are the same until you reach this step. Once you reach this step, and instead of 1.2, you divide by I base, you divide by Z base, you divide by V base. So what is I base? If you do I base, it will be the same number, 1.2. So if you do I base, it will be 1.2. That's why he put here 1 angle minus 36 point. You see this 1 minus angle? Because it happened to be I base equal to this current. What is this quantity? Vs prime is equal to V base. What is V base? 13.8. What is Vs prime? 13.8. Divide them, you will be 1 per unit plus 0.01. From where the 0.01 came? From the resistance, is 1%. And J, 0.07 from what? The impedance, 7%. So if you do it in the per unit system, you will have the voltage regulation ready in front of you. It's 5.1%. You see it? It's 1.05, 2.73 per unit. Multiply this by 13.8, you should get this number. So do you understand now the per unit system? If you use the equations, you should be able to solve it. Again, in summary, what is V base here? 13.8. What is S base? 50. What is S1 base? 50 by 3. What is I base? Is 50 over 3 divided by 13.8, which is 1.2. What is Z base? Go back to previous problem. We solved it. If you divide these quantities by the corresponding base, you should get these numbers. Who doesn't get it? This is the third problem in the homework, okay? With that, we finished what is required from the transformer. But there are things that you should know. But we're not going to ask you on the test. Do you remember this from the lab? Read the title. Finding values of transformer model. Open circuit test, short circuit test. Where is this? Where did we hear it? Did you do that up?
Yeah. We did it, I think.
So why you did not say we didn't do it? Because your lab is tomorrow. Okay, who's not taking 361? That's not a smart message. Messing around with plans is not a good idea. It's better to take the lab with the course. Why are you taking next semester? Do you think you'll get more knowledge? You'll forget. General recommendation is take it. But anyway, because you're doing it in the lab, we decided not to do it in the lecture. So this is included in the final exam of the lab, theoretical final exam. So I'm not going to ask you twice. But open circuit test to find the core components. See, the short circuit test is to find the R and the X equivalent in the series. How to do it? You already know how to do it in the lab. You open the voltage, you apply voltage, you measure voltage and current in the primary side. Then you get the power factor using the tool. You get the admittance, which is I over V, and then you get 1 over R minus J1 over X. Then the reciprocal of every number is what? Your components. How about short circuit test? You apply voltage and current, you short circuit the output, then you get the power factor, you get the impedance, which is what R equivalent plus, if they're using circuit 3. Let's continue. Open circuit test measurements are usually, not always, taken at the secondary since lower voltage is easier to deal with. The short circuit test is at the primary side. Hence, one of these quantities has to be referred to one another. So you have components, one referred to primary, usually one referred to secondary. When you write circuit 1 or circuit 2 or circuit 3, you need to refer properly, okay? That's the purpose of this slide. I'm not going to ask you to do the example. This is a numerical example for your own knowledge. What else we're not going to ask you in the test? The multi-secondary transformer. From its name, multi يعني ايش؟ متعدد. Secondary يعني الcoil, secondary. Transformer. For example, if you look at this multi-secondary winding, you apply 110 volts, then you get 1, 2, 3, 4. Maybe here they get 6 volts, here they get 5 volts, maybe here to power simple light bulbs, or fans, or USB, whatever. Then the main ones in red, they're taking 350 and 350. 350 plus 350, what? You can get 700 here, or you can get 350 here and 350 here. Maybe this send it to house 1, this send it to house 2. Get it? It's there. Here they call this center tap transformer. Center tap transformer, it means the tap is at the center of this coil. This is hot. Remember, red is hot. Cold. Hot. Is this hot or cold? It's not working. Is this hot or cold? It's yellow. Neither. Okay? It means it's not dangerous yet. There is another thing is we call the taps. Look at this example. You might have a transformer of 200 to 100, step down, with 2.5% tap on the primary winding. What does it mean? It means that the nominal tap, nominal يعني rated, not rated, ratio is 20 to 100, 200 to 100. Add 2.5% on the secondary, it will be ratio 100 to 1.2.5, or to 105, or to 95. What is the benefit of the tap? You can have one transformer, different taps, so to match whatever needs you have. Maybe if you get a bigger refrigerator, maybe you want to increase the tap to 5%. To give the big refrigerator 105. That's why if you buy equipment, you read them, sometimes they say 110 to 115. It means it works with transformer with any of these taps. Rated. What else? We have the TCUL. What is TCUL? Tap changing under load. It means that if the transformer is operational, I can change the tap while it's running. No need to turn it off. What is a voltage regulator? A voltage regulator is a subcategory of TCUL with a feedback loop that senses the voltage and adjusts the tap settings automatically. One of the benefits of the voltage regulators used in real life, or the term regulator, is usually you have here, for example, 0.9 per unit. Your voltage regulator will make the secondary 1 per unit. يعني over the system that has voltage drops, the regulator will boost up your voltage from, let's say, 0.9 to 1 per unit. Get it? يعني لو عندك الفولتج 115 over long distance it dropped to be 110, you put a regulator, it goes back to 115. Or 0.9 per unit to 1 per unit. منظم. Auto transformer. Auto transformer is a regular transformer, but with a certain connection. What is the connection? In the primary side, it's okay, but you series the primary lower coil with the upper coil of secondary. Why? When I apply VP, I get NS plus MP. This is a trick. I'm using the secondary coils to count in my primary. But in the secondary side, it's the same. It is MP, NS. So what will happen?
It will step down more.
It will step down more, but conservation of misery. What's the misery we have? The misery is those are not physically separated. خلاص, they be cables connecting. Remember, in the regular transformer, these are physically separable. If there is short circuit here, nothing bad will happen here. But if there is a short circuit here, the current will propagate to secondary and it will damage the load. Conservation of misery. If I don't have auto transformer, these are physically separated, electrically separated. ما في كيابل between them. But if there is no short high current here, بيروح للسكندري. Might damage your load. So you are right. The ratio now is larger. What is the ratio? Is NSE plus NC over NC, bigger number. That's a trick. It's very similar to the multi-coil winding trick. I am not going to do it. Go ahead and do it. Oh, there is one device I forgot to call. There is this device that called Variac. Variac is an auto transformer with sliding tabs. Sliding. It goes from 0 all the way to N2 plus N1 plus N3. It's a single coil with a sweeping arm from the center common that allows the ratio of primary turns to secondary. Coil واحد. In reality, it's just the one coil. We are done with this very long chapter that took so much time. So now it's time to go to the module 3. What is the title of module 3?
PC
Alright.
Who said DC mode? You are right. So what's the first step when you get introduced to a new topic?
Methodology?
Let's go and read about it online first, okay? Any news about the substation? Let's check the substation. We got 3 reviews more. Let's look at the photos. There is no photo. Where is your photo?
I have got. Yeah.
Maybe they didn't approve your photo.
No, good though.
Okay, who's this?
It's me.
It's you? Oh, let's look at your video.
Where is the substation?
This is who else participated? That's it. We don't have photos. We want someone to put photos. Well, I got 2 more reviews. Anyway. So let's look DC motor. These are sold online. So let's look at the Wikipedia page. DC motor is an electrical motor that uses direct current to produce mechanical force. That's the definition. Okay? It's very simple. No need to read everything else. That's the definition of a DC motor. So DC motor, it doesn't mean it produces DC speed. There is nothing called DC speed. It's spinning. But the way it spins is based on the fact that we're using DC current to produce mechanical force. So what is this DC current that produces mechanical force? So let's look into it. Now we started 03 revision 1. So how many revisions we got? 13 revisions for module 2. This one maybe we'll have 2 or 3 revisions. Maybe 4.
Is this topic included in the calculator?
To be decided.
Mister, we have an opinion now to change it if you increase the material, the major, to make it mid.
It's not a mid, it's a major.
No, I know. Do we have the opinion to change it?
No. I need to agree with other sections. This is a part of the soft coordination. I
But
can.
it's not coordinated, yes?
To me, I want it until the lecture the day before. So October 20. No, October 19. October 21st. The one we have the quiz 3. So we're gonna have the fake quiz, remember? Sometime next week we'll have the fake quiz. Okay?
وش بيكون الماتيريال؟
Everything. No, not everything. I'll tell you. Maybe 3-phase transform. Most likely. See, the semester is almost done. With November, خلاص. After November, we're done.
نص اصلا ديسمبر اختبارات.
Yeah, that's what I'm telling you. The best job is to be a student because you get more vacations. But you don't believe it. Those who did co-op know this fact. It's better to be a student. Anyway, do you remember the coil moving in a magnetic field? So let's pretend this is a coil, okay? Just coil made of what? Copper. This coil experiences a magnetic field into the page. X يعني إيش? Into the page. And I'm sliding it at a speed v. What will happen? Physics say 102, an induced voltage with plus, minus will appear on this coil. If I close the circuit, current will flow. Does it make sense? While I'm moving it, current will flow. The moment I stop, current will not flow. The voltage will disappear. So as long as I'm moving, what will happen? Induced voltage will appear. But there is space of movement. I cannot use it for motoring application. What if I have it as rectangle? If I move it this way or this way, I will get some sides experiences some movement. And I can close the circuit. Can I have it as a circuit? I can have it as a circuit coil. But as long as I'm moving in the magnetic field, I would experience a voltage. So do you remember this from physics? E equal V velocity times magnetic field times the length. So this is cross multiply. It means we look at the sine theta of the angle. So if you do the whatever right hand rule is if you do into the page No.
لا أول شيء اتجاه الحركة كذا تصير فوق.
This, okay, this one is into
لا كذا أول شيء تأشر
أي سبابة.
كذا وكذا وكذا فوق.
Okay. كده. So that's my V. Into the page is my X, my F, my B. And what is up?
F
No, the plus sign. I don't know how to do it, but what I know is my favorite. This one is my favorite. Okay? This one, you cannot up. If you have 3 variables, you cannot have this. So, if I close the circuit, current will flow. You agree with me? So this is what we call the generator action. What if I have the same, but I'm sending current from top to bottom into the page, magnetic field, and I'm pushing current in, going down. So if we do the right hand roll, my coil would experience a force that is moving. But if it experiences a force until moving, there is a limited space, there's no benefit. But if I make it like this coil, something like that, this side would experience a force where? This way. This side would experience a force, this up, let's say up, pretend. This one down. What is the ultimate thing? It will spin. It will spin. That's why electric motors are cylindricals with coils that look like that. This is the beginning, this is the end. So magnetic field would spin them if I apply current. It's very simple. If I have a coil that's like that, it will be going this way. If I spin it, it depends on the cross multiply. This side will experience a force this way. This side will experience the force up. This side down. What is the ultimate result? Torque will be applied. Torque on the structure. Get it? And we get students complaining about physics 102. If you don't get A plus in physics 102, do not go into electrical engineering. Because if you notice, most of the stuff in here has a concept in physics 102.
It's the last 3 chapters or 4 chapters.
Everything. Everything. Time is up. But this is what motoring action. Continue next. Let's check the camera.